So, all we have is we have our acceleration here, and now that we have that, we can go back to this formula that we were talking about yesterday at the top. Vf squared equals vi squared plus 2a delta y. We know the final velocity. We know the initial velocity. We don't know the final velocity. That's what we're looking for. We know the initial velocity. We know the acceleration now, and we know the delta y. So we can plug everything in. We will have, let's see, what's this color? Okay, so we have Vf equals square root Vi,
which is 0,
squared plus 2 acceleration delta y. Okay, and the initial velocity is 0. So this becomes Vf equals square root 2 times the acceleration that we came up with, which was negative 4.9 meters per second squared, and then times delta y. And remember, delta y is y final minus y initial. So that will be 0 minus 3, which is negative 3.0 meters. And so the negative times negative becomes positive. So we have a positive underneath the square root, which is very important, of course. And we have the square root of, just estimating, 6 times 4.9, like square root of 30. So it'll be a little over 5. What's our answer? 5.422. So with significant figures, it'll be 5.4. And it's a velocity, so the unit should work out to be meters per second.
It was down. 2 times it does. 4.9 times negative 3. It does work out.
Yes, meters
Squared per second
squared per second squared rooted is meters per second. So we're good. And that's what we're looking for. That's the entire problem. So we're done. And like I said, it was
gonna crush the truck.
5.4 meters per second. So double it and add a little for miles per hour. Just gonna hit the truck at
10 miles an hour.
more than that. Probably more like 15 miles per hour.
Yeah, it's gonna.
1,000 kilograms at 15 miles per hour.
And especially
Yeah.
the bed of a Ford, it's just.
We don't know if it's the bed of a Ford, but yeah, it's gonna do some damage. It's not smart. Okay, last problem for the section.
Yeah.
All three 50-kilogram blocks are at rest. Is the tension in rope 2 greater than, less than, or equal to the tension in rope 1? We'll need to think about this for a second. One is fixed to the wall, and then the other one, or the ceiling, and the other one is, the other two are hanging equally on the pulley. All right, if you were to think about this in terms of vectors, which is what you should always be thinking, free body diagram for rope 1, we would have 50 kilograms, so we'd have an mg down, which means we'd have a tension force equal to that up. For rope 2, we'd have an mg down here, which means we'd have a tension force of mg up as well. But that means that tension force of mg would be wrapping around the pulley and coming down the other side. We'd have an mg down here and an mg up. So there's an mg tension force in rope 2, and there's an mg tension force in rope 1. They are equal to. That's the answer.